Okay, so here we're talking again about finding the limit of a sequence. Uh, Trying to find out whether it has one or not. So here we have the sequence n, that's 2 over n. So let's just start computing that for some values. So for example, we put n equals 1 in there. That would be 1 to the 2 over 1 to the second power, which would be 1. Okay. Then we go in 2 to the 2 over 2, so that would be 2 to the 2 over 2 to the 1, which would just be 2. Okay. And up next we would have 3 to the 2/3. So now we need to kind of bring in some technology here. 3 raised to the 2/3, 2.08. So this, for the moment, seems like it's getting bigger. Now we come to n equals 4. That would be 4 to the 2 over 4, which would be 4 to the 1/2. And actually, we start to come back down now to 2. And then one more, 5 raised to the 2 over 5, 1.903. I'm just going to say 1.9, and then this pattern continues. We could go on and maybe do 6 to the 2 over 6 power. Okay, it certainly seems like at least now it's starting to get a little smaller. Okay, but the question really remains, does this thing converge, or what happens? Does it converge? So to determine the convergence of a sequence, what we do is we look at the limit as x goes to infinity of the underlying function, which would be x to the 2 over x. But as we go to infinity here, we recognize this as an infinity. X is going to infinity, but 2 over x is going to 0. So this is an infinity to the 0 limit. So remember, for those kind of limits, we step away from that piece for the moment and talk instead about the limit as x goes to infinity of the ln of that stuff. Again, we use our properties of logarithms to bring the exponent out. That was really the whole reason we did that. So we have 2 over x times the ln of x, right, which is now a 0 times infinity limit. And remember, for 0 times infinity limits, right, we write it as one of those things over the reciprocal of the other. It either transforms it into a 0 over 0 or infinity over infinity limit that we can then start to work out using L'Hopital's rule. So here it's much, much easier if we put the logarithm on the top. Put the logarithm on the top over the reciprocal of 2 over x, which would be x over 2. Right. We then recognize we have infinity over infinity, so we invoke L'Hopital's rule. Limit as x goes to infinity of 1 over x over 1/2, and we can clean that up just a little bit. Limit as x goes to infinity of 2 over x. Right, and now as x goes to infinity, 2 over x goes to 0. So the limit of the ln of x to the 2 over x goes to 0, but we want it the original limit, so we take and raise e to that answer. So we get that the limit as x approaches infinity of x to the 2 over x is equal to e to the 0, which is equal to 1. So therefore, this sequence converges to 1. This sequence here actually is going to converge to 1.